Hello everyone, and welcome to today's chem lesson. Today, we're going to talk about empirical and molecular formulas, what it means, what's the difference between an empirical and a molecular formula, and also some of the types of problems that you can be given that refer back to these concepts. Now, when we look at these two words, empirical, molecular, in terms of formulas, when we look at an empirical formula, molecular formula. An empirical formula is the simplest that any formula can be. It is reduced down to its simplest ratio. A molecular formula is based exactly on the molecule. It will represent exactly what is in the molecule. For example, something like this, C2H8. This represents exactly what is in a molecule. This is a molecular formula. Now, when I want to get the empirical formula, I would reduce these subscripts down to their most basic ratio. A 2 to 8 ratio is the same thing as a 1 to 4 ratio. And so, my empirical formula would be C1H4, reducing the subscripts down to their simplest ratio possible. Now, sometimes when we look, certain things have empirical formulas and molecular formulas that are the same. Water is a fantastic example of that. The stuff that is in one molecule of water is already at the simplest ratio. Sometimes you get two different things, two different molecular formulas that end up with the same empirical formula because they have the same ratio of atoms, and that's fine too. Molecular formula is all about exactly what is in the molecule. While empirical formulas are all about the simplest ratio. Of atoms. For sugar, C6H12O6, each one of these subscripts can be reduced by a factor of 6. Right? Divide all three of these by 6 and you get 1, 2, 1 for our empirical formula, finding that simplest ratio. Sometimes a question will ask you to find an empirical formula, to look at a molecular formula and reduce its ratio. Other times, you will be given an empirical formula and asked to find the molecular formula, which is a little bit more tricky because, like we can see here, CH can become C2H2 or C6H6. Right? There's multiple options to go backwards from empirical up to molecular. And so we need a little bit more information and a little bit more setup to solve a problem like that. Let's look at some of those problems now. Right here, we have two problems. They both give us the same bit of information. They both give us an empirical formula and the molar mass of the full compound. And they want us to find the molecular formula. Now, the relationship between these things is the inverse of what it would be to go from molecular to empirical. To go from molecular to empirical, we divide. We simplify by dividing. So in order to go from empirical to molecular, we're going to have to multiply. We're going to undo the simplification with multiplication. But the problem is we don't know what number to multiply by. We don't know how much we reduced with this information that we've been given. And that's why they give us the molar mass. Because if we know the mass of both pieces, we can find the relationship between these two. And that same relationship between the mass of the empirical formula and the mass of the molecular formula is going to be the same as the relationship between the ratio of atoms. And so if we can find the ratio that we use to convert from this mass, the empirical mass, to the molecular mass, we can use that same exact number to go from empirical formula to molecular formula. All right, let's see how that's going to work. We'll do this one in red. They give us an empirical formula of NH2. They ask us to find the molecular formula. And they give us the molar mass of 32 grams. Now we're missing this number here. We're missing the mass of the empirical formula. But we can get that by looking at the periodic table. If we look in the cells of the periodic table, we can find the mass of each of these pieces. So 1 mole of NH2 would weigh 14 plus 1 plus 1 for a total of 16 grams. And now with 3 of our 4 pieces, we can find the ratio. To go from 16 to 32, I multiply my whole thing by 2. So if I'm doubling the mass, I must also be doubling this ratio, which will make my final answer N2H4. And if we wanted to double check ourselves, we can just do the math on this. 2 N's, 14 and 14 is 28, plus 4 H's, so 28 plus 4 gives me 32. So that matches up, and we've solved our problem. Let's look at this second one. They give us the same set of information, right? The same set of pieces, obviously different identities and different numbers. They give us CH4N as our empirical formula. They give us 90 grams per mole for the whole compound. And they ask us again to find the molecular formula. This same piece of information is conspicuously absent. We can find it, again, by consulting the reference table. If I want to find the mass of CH4N, I can take 1 carbon, so 12, 4 hydrogens, making it 16 total, 1 nitrogen, making it 30 total. Then I'm going to look and see this ratio. I'm going from 30 to 90, which means I'm multiplying by 3. If I'm multiplying the mass by 3, I should be multiplying the formula by 3, which will give me C3H12N3. And again, if we wanted to double check ourselves, we would add together 3 carbons, 12 hydrogens, and 3 nitrogens, and find that that does actually equal to 90 grams exactly. You cannot go from an empirical formula to a molecular formula without any other information. You need the masses to find that ratio, or you need other pieces of information in order to solve it out. You can't just go from empirical to molecular. Let's look at some more practice problems. Here I've got 3 practice problems for us. I'm going to give you about a minute of time, a minute and a half worth of time. Again, please remember to pause if you need more time for you to work on these problems, and then we will go over them together. Let's take a look at these 3 problems. When we look at the answers for these 3 things, we should get this. The first problem just wants you to reduce down. They're asking you for the empirical formula. So you take C4H12 and you simplify those subscripts. 4 and 12 are both divisible by 4, giving you 1 and 3. For our second and third problems, we're looking at the same setup from the previous slide, going from empirical formula to molecular formula. And so we're going to end up with the same setup that we used before. Putting in the information that they gave us, solving to find the mass of the empirical formula, finding the ratio, and solving for our final molecular formula. The same thing down here for our third one. They give us N2H with some mystery molecular formula with a mass of 174 grams. We can look here and find that 2 N's and an H weighs 29 grams, meaning we're multiplying by 6 to give us N12H6. Now, to close us out for today, I do just have one final multiple choice practice problem for us. Which of these 4 formulas is an empirical formula? When we look for an empirical formula, we are looking for something that cannot be simplified, right? Or something that is already in simplest form. And so when we look, choice 1, C2H2, that can be reduced down to C1H1. Same thing for H2O2, that can be simplified down to H1O1. Same thing for choice 4, these 6, 12, and 6 can be simplified down to 1, 2, and 1. Which means the only one of these things that is in its simplest form, the only one of these that cannot be simplified any further, is choice 2. All 4 of these are molecular formulas. All 4 of these show exactly what is in a molecule. But the only one of them that is also an empirical formula, the only one of them that is in simplest form, is choice 2. And with that, I'm going to transition us over to our Zoom meeting for questions, comments, concerns, and attendance. And I will see you there.